Hello everyone, this is Teacher Chan, your math companion for today. In today's video, the topic is all about divisibility rules for 8 and 12. Before we go further discussing all the lessons about this topic, let us first answer the problem or the task that was given in the previous video. And the task was, you're going to find the least digit to make the statement true. And here is the statement. It's 4,500 blank 4 is divisible by 3, 6, and 9. Now what do you think is the missing digit? The smallest or the least missing digit to make the statement true. Since that we're looking for the smallest or the least missing digit, so we always have to start from 0. Shall we try? Alright. So I have here 4,500 blank 4. If we're going to fill it with 0 and try to check if it's divisible by all of these numbers here, the 3, 6, 9, remember the divisibility rule number 3 says the sum of all the digits should be divisible by 3. Now let's find out the sum. 5 plus 5 plus 0 plus 4 is? What is the sum? You're correct. It's 13. And 13 is not divisible by 3. Neither 6 nor 9. Right? How about 1? Let's try 1. If we write 1 here, the sum is, a while ago it's 13. We just add 1, it becomes 14. And 14 is still not divisible by 3. Nor 6, neither 9. How about 2? It's 14, so plus 1 becomes 15. Do you think 15 is divisible by 3? Exactly, because 15 is a multiple of 3. If we skip count 3, 6, 9, 12, 15, we say that it is divisible by 3. But remember, yes, it is also divisible by 6, but remember, it is not divisible by 9 since 15 is not a multiple of 9. So let's find another number. How about 3? 4 plus 5 is 9 plus 3 is 12, plus 4 is 16, and 16 is not divisible by any of these numbers. How about 4? If it's 4, then 12 plus 5 is 17, not also divisible by any of these numbers. How about 5? If we're going to add all these digits like 4 plus 5 is 9, plus 5 is 14, plus 4 is 18. And 18 is divisible by 3. And it is also divisible by 6 because it's even, and it's divisible by 3. And it is also divisible by 9 because 18 is a multiple of 9. So we say that the smallest missing digit is 5. So for those who got the correct answers, congratulations. And for those who did not make it, just do better next time, okay? So since that we're done already answering the question of the previous video, let me proceed to our topic for today. Since that we discussed already a lot of divisibility rules since the first video, to mention some, we have divisibility rules 3, 6, 9, 2, 5, 10, etc. In today's video, we're going to tackle about the divisibility rules for 8 and 12. But before, let me first give you this problem. The problem is, Bruno wishes to know if 816 tennis balls can be packed in 4s, 8s, or 12s. So the question here in the problem is, can he exactly pack all the tennis balls in 4s, 8s, and 12s, making sure that there is no excess or remainder? That's the problem now that we're going to solve to help Bruno. To solve this problem, we need first to learn the divisibility rules for 8 and 12. And let's begin in divisibility rule number 4. It states here that a number is divisible by 4 if the number formed by the last two digits is divisible by 4. What does this condition mean? I'll give you an example. I have here 136. What is the number formed by the last two digits? But to simplify, what are the last two digits? It's 3 and 6. So what number is formed by the last two digits? It's 36. Let's try to check this 36. Is it divisible by 4? Let's try to divide. 36 divided by 4 is... Now, if you are well versed of multiplication table, then it's easier for you to divide because you just have to skip count at times. Like 4, 8, 12, 16, 20, 24, 28, 32, 36. There are 9 fourths in 36. So we say that the quotient is 9 and there is no remainder. It means to say that it exactly divides 36. Now we can already conclude that 136 is divisible by what? By 4. Look at that. It's easier for us to identify if it's divisible by 4 by just getting the last two digits. Another example. 25,400. Now, what number is formed by the last two digits in 25,400? It is, yes, 0. Now search on what will happen if the last two digits are zeros. You don't need to worry anything because according to the rule, once the last two digits are zeros, it is divisible by 4. Any number that ends with two zeros like 100, 1,000, 200, 1,000,000, 100,000, etc. I know that you have a lot of numbers that ends with two zeros in your mind. Okay? And those numbers are all divisible by 4. So we say that 25,400 is also divisible by 4. How about this number here? I have here 25 or 23,518. Do you think 25,518 is divisible by 4? Let's find out by checking the number that is formed by the last two digits. It's 18. Is 18 a multiple of 4? Try to skip count. Instead of multiplying, sometimes we need to skip count to make it faster. Like 4, what? 8, 12, 16, 20. Oh, there is no 18 in the multiples of 4 because 18 is between 16 and 20. Therefore, we say that this number here is not divisible by 4. Alright? So you know already how to check if it's divisible by 4. Now it's time for us to proceed to the divisibility rule number 8. Now according to the condition here in divisibility rule number 8, it says that a number is divisible by 8 if the number formed by the last 3 digits is divisible by 8. It sounds similar to 4, but in divisibility rule number 4, we only have to get the 2 digits. But here, we need to get the number formed by the last 3 digits. So I have here an example for you. I have here 8,128. Let's find out if this number is divisible by 8. What is the number formed by the last 3 digits? It's correct. It's 128. Now the question is 128 divisible by 8? Now it's a little tasky. I know, it's a little tasky in this part because you really have to divide the 3 digits by 8. Okay, and it can make our solution easier if we're going to use the vertical division instead of horizontal. Let's try to add this. Let's try to divide this. I have here 128 from this number divided by 8. Let's begin. 12 divided by 8. Okay, I already jumped into 12 because 1 divided by 8 cannot be. So 12 divided by 8. Yes, it's 1. 1 times 8. It's 8. 12 minus 8. It's 4. Next step is, after subtracting, definitely bring down the next digit. The next digit after 12 is, it's 8. Now what is 48 divided by 8? I told you, if you are well versed in multiplication table, it is easier for you to divide. You just have to skip count. Like 8, let's try to reach 48. 8, 16, 24. What's next after 24? 32. After 32, 40. After 40, 48. There we go. Now, how many 8s are there in 48? There are 6. Now, what is 6 times 8? Definitely 48. Next is subtract again. 48 minus 48 is 0. Do you have anything to bring down? No more. So that ends our division. So what is the remainder? 0. There is no remainder. It means to say that 128 exactly divides by 8. And we say now that 8,128 is divisible by what? By 8. Now that is how we're going to check if it's divisible by 8. How about 10,000? Like 10,000. Like that. What do you think? Yes, you already see the last 3 digits. All zeros. You have 0, 0, 0. Do you think these 3 zeros are divisible by 8? What is 0 divided by 8? It's 0. It means to say that this number here is also divisible by 8. Similar with 4. I told you, if a number ends with 2 zeros or more, then it is divisible by 4. But in 8, if a number ends with 3 zeros or more, then it is also divisible by 8. You know already how to check the divisibility rule number 8. It's time for us to proceed to the divisibility rule number 12. A number is divisible by 12 when a number is divisible by 3 and 4. So for you to confirm that it is divisible by 12, you have to check first the divisibility rule number 3 and 4. Making sure that a number is divisible by 4 and a number is divisible by 3 as well. Then we can say that that number is also divisible by 12. Yes, it's a little tasky because you have to do it step by step, like check the divisibility number 3, 4, and then confirm if it's divisible by 12. Let's do it by using the divisibility test. Now I have here an example for you. It's 13,032. Let's find out if this number here is divisible by 12. Alright? So let's begin by checking the first condition. Is it divisible by 3? What is again the divisibility number 3? Now if you did not watch yet the video about divisibility number 3, please watch it first for you to understand more on divisibility rule number 12. So it is stated in the divisibility rule number 3 that a number is divisible by 3 if the sum of all the digits is divisible by 3. Let's add all the digits. 1 plus 3. What is 1 plus 3? It's 4. Right? Plus 0, plus 3, plus 2. I'll give you some few seconds to try to get the sum of these digits here. Let's try. What is your answer? You're correct. The answer is 9. Now, is 9 divisible by 3? Definitely, because it is a multiple of 3. 3, 6, 9. There is no remainder. So we say that this number here, the 13,032, is divisible by 3. Now, can we already confirm, or can we already say that it's divisible by 3 since it's divisible? Now, can we already say or confirm that it is divisible by 12 since it is divisible by 3? Not yet, because we did not check yet the divisibility rule number 4. And here we go. What is the condition in divisibility rule number 4? A number is divisible by 4 if, correct, if the last 2 digits, or if the number formed by the last 2 digits is divisible by 4. Now, what are the last 2 digits here? Awesome. It's 32. Now, do you think 32 is divisible by 4? Correct. It is divisible by 4 because 32 divided by 4 is 8 without remainder. So since that it is exactly divided by 4, then we can say that it is divisible by 4 as well. Since that we're done already checking the 2 conditions here, it's time for us to check the divisibility rule number 12. First, is it divisible by 3? Check. Divisible by 4? Check. So we now say that it is also divisible by 12. I know that you are asking why do we have to check first if it's divisible by 3 and 4 before checking the divisibility number 12. It is because, remember, 12 factors are 3 and 4. Did you get it? What is 3 times 4? It's 12. That is why we have to check first if it's divisible by 3 and then if it's divisible by 4. If these 2 conditions are answered, then the number is divisible by 12. Since that we're done already discussing the 3 divisibility rules today, it's time for us to go back to our problem and try to answer it. Now let me read the problem for you again. Bruno wishes to know if 816 tennis balls can be packed in 4s, 8, and 12s. Can he exactly pack all the tennis balls in 4s, 8s, and 12s? That's the question. Let's try to use our learning about the divisibility rule for 8 and 12. Write in the number here 816 to check if it can be packed or it can be divided exactly by 4, 8, and 12. And we are still using the divisibility test. This table is very useful, so I advise you if you're gonna check some number, if it's divisible by another number, then you better use this table because it is very organized. So the first thing that we're going to do is to check if it's divisible by 4. By looking at the last 2 digits, it's 16. I know that it is a multiple of 4 because 4, 8, 12, 16. You see? So it is divisible by 4, the last 2 digits, or the number formed by the last 2 digits. So we say that it is divisible by 4. So it means to say that 816 tennis balls can be packed by 4 exactly. How about 8? What is the last 3 digits? That's the condition in 8, right? Check the last, or check the number formed by the last 3 digits. What is the number formed by the last 3 digits? It's 816. I know that it's a little tasky because you still have to divide it using the vertical division. Let's start. 816 divided by 8. Let's begin. What is 8 divided by 8? 1. What is 1 times 8? 8. What is 8 minus 8? 0. Bring down 1 digit. Remember, you have to bring down 1 digit at a time. That's the rule in the division, right? So what is 1 divided by 8? cannot be, or 0. So we write 0. 0 times 8, that's 0 again. 1 minus 0, 1. Bring down another digit. 6 is the last digit. So 16. 16 divided by 8, 2. 2 times 8, exactly, it's 16. 16 minus 16, 0. Do you have any digit to bring down? No more. Is there any remainder? None. So it makes our dividend exactly be divided by 8 without remainder, so we say that it's divisible by 8. Here we go in the most challenging part, checking the divisibility rule number 12. To check the divisibility rule number 12, we have to first check these two. Make sure that it's divisible by 3 and as well divisible by 4. First, let's add all the digits to see if it's divisible by 3. 8 plus 1 plus 16. I'll give you 3 seconds to think of the sum. 8 plus 1, 9, right? 9 plus 6, correct, it's 15. So 15 divided by 3 is what? 3 or 5? It's 5. There is no remainder, so we say it is divisible by 3. Next, is it divisible by 4? Yes, because we already checked earlier. So we say, since it is divisible by 3 and 4, now we say that it is also divisible by 12. So since we're done already checking if it divisible by these three numbers, 4, 8, and 12, then we can already help Bruno answer his question or his problem. And we say that Bruno can exactly pack all 816 tennis balls in 4s, in 8s, and in 12s. Did you get it? Okay. Now to enrich your understanding about divisibility rule number 4, 8, and 12, let's answer first this problem. Now in this part, I want you to encircle the exact divisor of the given numbers. First, the given number is 1024. To check if it is the exact divisor of the given number, of course we're going to use the divisibility rule for 8 and 12. Is it divisible by 4? Yes, because the last digit is 24, and 24 is a multiple of 4. Let's encircle. Next, is it divisible by 8? What is the number formed by the last 3 digits? It's 24 also, 0, 24. So we say that it is divisible by 8, because 24 is a multiple of 8. 8, 16, 24. Exactly. So we say that 8 is also an exact divisor of this number. How about 12? First, check the divisibility to number 3. Is the sum divisible by 3? 1 plus 0, correct, 1 plus 2. Yes, it's 3, and 3 plus 4 is 7. So is 7 divisible by 3? No. Since that in the first checking, it is not divisible by 3 already, so we say that this one here is not divisible by 12. So we say now, so that makes 8 for exact divisors of 1024. Next given number, 3120. Is it divisible by 4? Yes, because the last digit is 20, and 20 is a multiple of 4. 4, 8, 12, 16, 20. Now, we encircle this. How about 8? What is the last 3 digit or the number formed by the last 3 digit? It's 120. Let's try to divide. 1 divided by 8 cannot be, or 0. 12 divided by 8, 1. 1 times 8, correct, it's 8. What is 12 minus 8? Awesome, it's 4. Then bring down, definitely 0. 40 divided by 8. How many 8s are there in 40? Let's keep count. 8, 16, 24, 32, 36. Mali. So how many 8s are there in 40? Let's keep count. 8, 16, 24, 32, 40. There are 5. So 5 times 8, 40. What is 40 minus 40? Correct, 0. Do we have remainder? No remainder. So we say that 3,120 is also divisible by 8. And that makes 8 an exact divisor of this number. How about 12? Let's add first all the digits to check if it's divisible by 3. 3 plus 1, correct, it's 4. Plus 2, 6. 6 is divisible by 3, right? Because 6 divided by 3 is 2. It's with 0 remainder. Okay, so check for the 3. How about 4? Is it divisible by 4? Yes, because we inserted already the 4 here. So that makes 12 an exact divisor of 3,120. Now what have you noticed here in the table? Two numbers here, the 1,024 and 3,120, have common exact divisors. What are those common? When I say common, the same exact divisors. Yes, they have 4 and both of them have 8 exact divisors. And that makes 4 and 8 common factors of 1,024 and what is the other number? 3,120. Again, that makes 4 and 8 common factors, the common factors of 1,024 and 3,120. Now, we're done already discussing all the divisibility rules for 8 and 12. So that ends our lesson for today. But before I will leave you, let me first give you this question. And this question will be answered in the next video. So I want you to drop your answers, all your answers in the comment section below, okay? So the task is, you're gonna find all possible values of the digit n so that 6,208 blank or n is divisible by 8. What do you think are the possible digits to make this number here a divisible by 8? Okay? So thank you so much for finishing this entire video. I hope that you learned a lot from our lesson today. This has been Teacher Chan, your math companion for today.